Now let's see for this reference string, this particular one. Let's see one thing. Let's do one thing. Let's try to observe what happens for the same reference string for a given algorithm with first 3 number of frames, and number of frames is 3, and next with 4 number of frames. So let's see both of them. Now let's examine this string using optimal. So optimal algorithm with 3 frames. Now 0 is required, 1 is required, 2 is required, loaded, and next thing is when 3 is required, which one will be replaced by optimal? So if you look at this optimal algorithm, so if 3 is required, so see which one is not required for the longest. 0 is required immediately, 1 is required immediately. I am talking about 3, right? 0 is required immediately, 1 is required immediately, but 2 is not required very soon. Therefore, this one will be replaced with 3. And next one is 0 is required, it is there, 1 is required, it is there. Now I am talking about 4. So when 4 is required, so in this frame, in the main memory I have 0, 1 and 3. So 0 is required immediately, and next 1 is required, but then 2 is not required. As 3 is required, but 2 is not required so soon, but 2 is not there. So 3 is not required so soon, so we are going to replace 3, right? And next 0 is required, it is there, 1 is required, it is there. And what about 2? 2 is not there. So which one will be the good replacement here? So 4 is required, and 0 and 1 are not required. So you can either replace 0 or 1. So let us say I am replacing 0 with 2. And next one is 3 is required. So which one is a good replacement here? 4 is required. Therefore you can replace either 2 or 1. 2 or 1 are not required anyway, right? So 3. And next 4 is required, and 4 is there. So how many page faults are there here? The number of page faults are, so how many do you think should be there minimum? If there are 0, 1, 2, 3, 4, totally 5 pages are continuously referred in the over everything, over the entire reference string, 5 pages are referred. Therefore at least there has to be 5 page faults, because it is demand paging, right? So 5 should be the minimum. Now 1, 2, 3, 4, 5, 6, 7. So page faults here is 7. So what is it? Using optimal algorithm, using a stack of 3, using a main number of frames as 3, I got the number of page faults as 7. Now for the same algorithm, instead of using the number of frames as 3, let me use number of frames as 4. Then I want to observe what happens for the same algorithm. 1, 2, 3, 4, right? So 0 is not there, loaded. 1 is not there, loaded. 2 is not there, loaded. 3 is not there, loaded. Fine. And next one is 0 is required. 0 is already present, no, not needed. 1 is already present, not needed. Now we need 4. So which one are we going to replace? Now just watch it. So 0 is immediately required, 1 is required, 2 is required, 3 is required at the farthest distance, right? Therefore 3 will be replaced with 4. Why? Because 3 is the one which is going to be required after a long time. That is why we are going to replace it, right? And next 0 is required there, 1 is required there, 2 is required, is present, and 3 is not present. Therefore which one are you going to replace? You can replace any one of 0, 1, 2. 4 is required next, but 0, 1, 2 are not required. So what I am trying to do is I could take this one and replace it with 3. I have choice here. And what about 4? 4 is not required, 4 is required and 4 is present. So how many page faults did we get here? 1, 2, 3, 4, 5, 6. So the number of page faults in this case is 6. Got it? So now what did you observe? As I allocate more number of frames, the page faults are decreasing, isn't it? Why? Obviously true. So if I have more capacity, then I'll try to accommodate as many pages as possible, and so in future if they are required, I need not load them again. So it is true, if I increase the number of frames allocated to a process, the actual tendency is the page faults should actually reduce, and it is happening in this case in optimal algorithm. Now let's check what happens for the same one using LRU, least recently used. So for the same reference string, if I use LRU and if I use 3 frames, then let's see what happens. So 0 is referred, it will be loaded. 1 referred, load it. 2 referred, load it. And what about 3? So if I have to load 3, something has to be replaced here. Using LRU, which one will be replaced? 0 will be replaced because that is very far away in the past. Therefore 0 will be replaced with 3. Fine. And next again I need 0. Then which one will be replaced if I need 0? So 1 is very far away, therefore 1 will be replaced. And next one is I want 1, right? Then which one will be replaced? 2 is very far away, therefore it will be replaced with 1. And next one is I need 4. Which one will be replaced? 3 is very far away, therefore that will be replaced. And I need 0. Which one will be replaced? Okay, 0 is already present, no need of replacing. 1 is already present, no need. And next one is I need 2. Now 4 is far away, therefore 4 will be replaced with 2. And next one is I need 3. Now which one is far away? 0 is far away, 0 will be replaced with 3. And next one is I need 4. Which one is far away? 1. Therefore like this. So how many page faults did we get here? So whatever algorithm it is, there have to be 5 page faults because there are 5 different pages, isn't it? So what about the other thing? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So number of page faults in LRU using this 3 frames is 10. Now let's use 4 frames and see what happens. 1, 2, 3, 4. Now initially 0 will be referred, yes, 0 is loaded. 1 will be referred, yes, 1 is loaded. 2 will be referred, 2 is loaded. 3 will be referred, 3 is loaded. And next thing is I need 0, 0 is already there. And I need 1, 1 is already there, but 4 is not there. Therefore which one will be replaced now? So if you watch it, 0, 1 and 1, 0, 3, 2. Therefore 2 is the page which is referred long back. Therefore it will be replaced with 4. And next one is 0 is required, it is there. 1 is required, it is there. And 2 is required. Which one will be replaced? 1, 0, 4. And the last one which is referred is 3. Right? 1, 0, 4 are referred earlier than 3. Therefore the farthest away one is 3. So it is replaced with 1. 2, right? Yes. It is replaced with 2. Fine. Next one is 3 is required. Then which one is replaced? If you see this, 2, 0, 1 and then 4 is here. Therefore 4 has to be replaced with 3. Right? And then 4 is required. So if 4 is required, which one is replaced? 0 is replaced and we get the 4. Now just look at how many page faults are there. 1, 2, 3, 4, 5, 6, 7, 8. So the number of page faults here is 8. Yes, both the algorithms are suggesting that our intuition is right. What is our intuition? That if I increase the number of frames, the number of page faults should reduce. That is what both are suggesting. Now why not we even test for FIFO before declaring anything like that? So let's see what happens for FIFO, first in first out. Okay, now if I use 3 frames using FIFO, what happens is, so 0 is referred, yes, loaded. 1 is referred, loaded. 2 is referred, yes, loaded. And next one is I need to refer, I am referring 3. So which one will be replaced? So now this one will maintain a queue, right? So 0, 1, 2 are in the queue. Now if I want 3, 0 will be replaced and 3 will be added, right? And next one is I want 0. Now which one will be replaced? 1 will be replaced and 0 will be added. So 1 will be replaced and 0 will be added. And next one is I want 1. So which one will be replaced? 2 will be replaced and 1 will be added. 2 will be replaced and 1 is added. And next one is I want 4. So which one is replaced? 3 will be replaced and I'll add 4. 3 will be replaced and I'll add 4. Right? And next one is 0 is required. So 0 is already there. 1 is required. 1 is already there. 2 is required. So which one will be replaced? 0 will be replaced and 2 will be added. And next one is 3 is required. So which one will be replaced? 1 will be replaced and 3 will be added. So 1 will be replaced and 3 will be added. And next one is 4 is required. So which one will be replaced? Oh, 4 is already there. So it is not going to be a miss. Got it? So how many page faults we got here? the number of page faults we got here is 1 2 3 4 5 6 7 8 9. So the number of page faults we got here is 9. Now let's increase the number of frames allocated to FIFO, right? So let us say 4. Then what does your intuition say? Intuitively we feel that the number of page faults, if I increase the number of frames, should reduce, right? That is what we intuitively feel. Why should it reduce? Because obviously we are giving it more space, so it is supposed to do some wide, it is supposed to save some of the pages and therefore reduce the number of page faults, isn't it? So let's see what happens here. So initially 0 1 2 3 will be referred. Since they are not there, they all will be loaded 0 1 2 3 in that order, which means I get 0 here, 1 here, 2 here, 3 here in the queue. And next one is again 0 is referred, 0 is there, 1 is referred, 1 is there. Check that 0 and 1 are there. And when I don't have 4, which one will be replaced? This one will be replaced and I need to get 4. Okay. And next thing is I need 1, I need 0. Then which one should be replaced? 1 will be replaced and I get 0. 1 will be replaced and I get 0. And next one is I need 1. So which one will be replaced? 2 will be replaced and I get 1. 2 will be replaced and I get 1. And next one is 2 is required. So which one will be replaced? 3 will be replaced and I get 2. So 3 will be replaced and I get 2. And next one is 3 is needed. So which one is going to be replaced? 4 is going to be replaced and I get 3. 4 is going to be replaced and I get 3. And next one is 4 is required. Then which one will be replaced? 0 will be replaced and I get 4. Right, now check it. How many are there? 1 2 3 4 5 6 7 8 9 10. Oh, page faults are now 10. Are you watching it? See, now what happened? I thought that by increasing the number of frames, the number of page faults will reduce, but FIFO is actually doing something other than that. So in case of FIFO, if I am increasing the number of frames, the page faults are increasing. Okay, so one thing is, for this particular example it happened, and it doesn't mean that for every example it will happen. Okay, so it doesn't mean that FIFO always by increasing the number of frames is going to increase the number of page faults. In this case, for this example, it so happened that for FIFO, first in first out, as I increase the number of frames, the number of page faults also increase, which is really weird, right? And this is called as Beladys anomaly. So Beladys anomaly means the scientist Beladys, the scientist Beladys has found out this trend, and that is why it is named after him. It is called as Beladys anomaly. So Beladys anomaly means if we increase the number of frames, FIFO is behaving strangely for some examples, right? So then what they did is they have conducted some experimentations, and then they found out that the algorithms which really show this behavior, they are called stack algorithms. So I'll tell you what a stack algorithm is, okay? Later in one example I'll tell you. But anyway, just observe that in case of, not just for this example, if you take any example, optimal will behave this way. As I increase the number of frames, then the number of page faults will decrease. Optimal or LRU are going to either decrease the number of page faults or stay same, but then they are never going to increase, right? But only in the case of FIFO, for some examples, even if I increase the number of frames, it is not going to decrease the page faults, and in fact it's going to increase them for some of the examples. And that is why this FIFO is having Beladys anomaly. And later I'll show you that there is some property which is inherent in FIFO, because of which this Beladys anomaly is happening, right? And this is a very important question. So I think it is asked 4 or 5 times. Which of the following has this property, that if I increase the number of frames, the page faults will increase, and FIFO is the answer. Okay, fine.